Hi everybody, welcome back to a new lecture for our groundwater cycle video or course. This is the use of groundwater, so this is our third video, and we'll describe the use of groundwater. So it's a fairly short video, very few slides, but it's more quantitative than the previous one, so there's a little more to memorize, I guess. So the goal here is for you to have a sense of how much groundwater we actually use, freshwater and groundwater, and what what industries, what activities actually consume fresh water and groundwater. So it's a little more quantitative because numbers are thrown, and it would be nice to remember, orders of magnitude, how much do we actually use. So if you remember the needs from last lecture, I talked about water for life and for livelihood. So here, the numbers, the basic numbers are 5 to 7 liters just to survive for a few days, right? Just to drink, basically, essentially, and then just prepare food if that. So this is really a strict minimum, like you won't survive without this much fresh water. Medium term is 15 to 20 liters. That allows you to have water for drinking again, food prep, and then some personal hygiene. Okay, so again, these numbers are the strict minimum that if you don't have it, you won't survive for long. And here is, to contrast that, how much we actually use. So on the left-hand side here, so both of those graphs here represent the same data, and that's again the per capita freshwater usage per person per day, right? So it's in liters, so you can see in the US, we're a more wasteful society, so we consume a lot of water, right? 560, 70, 80 liters, 580 liters per day per person. So again, contrast that to 30 liters, minimum to survive, that's almost 20 times as much, right? On the right-hand side here, excuse me, let me grab my pen. So here you can see 50 liters per day, per person per day, is considered, water poverty threshold, right? So if you have 50 liters per day, as I said before, you need 20 to just survive. 50 liters is considered, water poor, basically, or the boundary with poverty, right? So you need more than 50 liters a day for livelihood, like I explained before, right? For being a productive, person in society, you'll need access to more than 50 liters a day. So again, if you look on the left-hand side, again, in the US, we consume more than 10 times as much. And then, you can go down the list of all the Western countries mostly. And then if you look at the bottom here, those countries are basically at the water poverty level. Again, on the right-hand side, the same data, just presented in a different way. These data are from the UN, so the Human Development Report from 2006 on the left, and the FAO 2006 report on the right-hand side. So here's another view of our use of groundwater. So on the left-hand side here, it's all water, basically, so all fresh water, so surface and groundwater. And the right-hand side, we have a split between surface and groundwater to sort of start looking into more of the groundwater aspect of things. So you can see right away that the activities that we use water for the most, right, is thermoelectric power and irrigation. These data are now for the US, not worldwide, in the US. So a lot of thermoelectric power, a lot for crop irrigation, so food production. Now, a note on the thermoelectric power, this is typically surface water that is used, and so it's really recycled. So that's water that goes through the thermonuclear facilities to cool down the reactors and then is released. So there is some thermal pollution of the water, but as far as water quantity, it's pretty much returned to the environment. So it's not really extracted and gone forever. And if you look at the next activity, it's irrigation, right? Obviously, irrigation of crop is a huge consumer of water, and this is what you can see here. Maybe surprisingly for some, but the next up, which is the public supply, so the water we really use, in our cities for our own, drinking water and hygiene, and the water we use in our homes is actually very much smaller than the water we use for food production. So that's something to keep in mind. Even though a lot of water engineering goes into distribution system and wastewater treatment plants, really the total amount of water we consume is mostly for irrigation. On the right hand side here, you can see the split between surface and groundwater. So notice that since the 80s, right, the total withdrawal is about constant, and since the 2000s, it's actually dropping. And again, if you look below, you can see that this is mostly due to the thermoelectric part of things, so that won't affect groundwater as much, right? And so on the right-hand side, you can see that the surface water is following that total trend. The total trend is here up top, right? And the surface water is decreasing because the thermoelectric is decreasing, but the groundwater here is about stable since the 80s, right? And if you look at orders of magnitude, you can see that the groundwater represents about 25 to 30% basically of the total water, right? So it's almost a third now. If you look at here, that's about 75 versus 250, right? So quarter to a third is groundwater and the rest is surface water. Interestingly, total water use is decreasing, but population is still increasing, right? So here it's stable and then decreasing, and the population itself just keeps growing, basically linearly. So that means that if we look at the per capita, if you remember from the first slide, I said in the US, it's about 580 liters a day. However, that has changed quite dramatically on the per capita, and now we're in US units, so these are gallons per capita per day. But you can see since the 80s that sharp decrease in per capita use, which gives a little hope, I guess, for the future. Now, if we look again at the split between surface and groundwater, you can see again 80 versus 200, right? So these numbers here, surface water, groundwater, that gives you an order of magnitude. Again, a third is groundwater-ish. Now, going back to those different activities that we use water for, the public supply here, right, is about 50-50. So this means, our cities, again, that would be 20,000 would be 50-50, right? So it's actually a little less, but same order of magnitude. So which means that a lot of cities actually get their water from groundwater sources. Conversely, again, if you live on a farm, you probably have a well here, right? So almost all domestic water is from personal wells. If you look at irrigation, again, 50-50, right? So this huge amount of water we use for crop and food production, actually half of it comes from groundwater. So that's, it's a very big number, right? Again, the thermoelectric already made that point, right? But you can see it's almost all surface water. So this, again, is just, going through the facility, cooling those reactors, and then going out of the facility back into the surface water pool. Okay, industrial is also very much, surface water driven. So again, if you look at where we use groundwater, well, irrigation a lot, and personal wells basically quite a bit. Oh, excuse me, on the right-hand side here, so the plot on the right-hand side is the same data, just with different illustrations. Again, the thermoelectric is this huge, bottom bar here. That's a lot of water, but it's all surface. Irrigation is a huge bar, so it's a different visual, basically, of this data. And then the public supply comes next, right? And then the industrial water and other activities in between are much smaller. Okay, so this wraps up today's lecture. So again, quite a few numbers. Try and remember orders of magnitude. How much do we need to survive? How much do we actually use per capita in different countries? The most, the least, and things in between, and which human activities basically drive our use of water. All right, thank you. I'll see you in the next video.